As your infrastructure grows, managing access isn't just about giving permissions, it's about controlling them with precision. You need a way to define who can do exactly what, while still keeping things flexible and secure for both users and automated systems. Vultr IAM enables this through fine grained access control using roles, role trusts, and permission policies to help you enforce least privilege access without adding unnecessary complexity. Hello everyone, I am Shivang Chandelier from Developer Relations at Vultr, and in today's Tech Talk, we'll walk through how to implement fine grained access control using Vultr IAM and see how roles, role trusts, and policies come together to give you precise and secure control over your infrastructure. So, let's get right into it. In Vultr IAM, permission policies are what actually define access. They contain explicit allow or deny rules on specific services and resources, making them the core building block behind every access decision. These policies can be attached to users, groups, or roles and are scoped at a very granular level down to the service, the action being performed, and even the specific resource ID. You can either use Vultr-Managed policies, which cover the common access patterns and are maintained for you, or create custom policies when you need more precise control. Overall, permission policies are what enable fine grained access by clearly defining what actions are permitted and where they apply. Roles are a collection of permission policies that helps you manage access in a consistent and scalable way. Instead of attaching multiple policies to each user or service individually, you group them into a role and assign that role wherever it's needed, making access control much easier to manage. There are two types of roles: assignable roles, which provide permanent day to day access by being directly attached to users, groups, or service users, and assumable roles, which provide temporary, time bound access through controlled sessions. The distinction allows you to handle both regular access and elevated privileges in a secure and structured way. In Vultr IAM, role trusts define who is allowed to assume an assumable role and under what conditions. This trust relationship can be set for specific users or groups within your organization, as well as external identities through OIDC, giving you flexibility in how access is delegated. Role assumption itself can be controlled based on desired conditions, whether it happens automatically or requires manual action, and can be limited through session durations to ensure access remains temporary. Additionally, trust expiration allows you to define how long this relationship is valid, ensuring that role assumption is tightly controlled and does not remain open any longer than intended. Now, let's talk about some use cases where fine grained access control in Vultr IAM really makes a difference. For example, in CI CD pipelines, instead of storing long lived API keys, you can use OIDC based role trust to allow your pipeline to securely assume a role when needed, making the process both safer and easier to manage. For teams like auditors or finance, you can grant read only access so that they can review infrastructure, billing, or logs without any risk of accidental changes. When working with contractors or external contributors, you can provide time bound access using assumable roles, ensuring their permissions automatically expire once their work is done. And for critical operations, such as debugging production issues or performing sensitive updates, you can grant temporary admin access. This way, elevated privileges are only available for a limited time, reducing the risk that comes with permanent high level access while still allowing teams to move quickly when needed. Now that we have covered the concepts, let's see all of this in action. In this demo, Sanskriti will walk us through creating a custom permission policy, setting up an assignable role for stable long term access, registering an OIDC issuer via the API to enable keyless federated authentication, and creating an assumable role backed by that OIDC trust with scoped conditions. So, let's get right into it.
Hi everyone, let's start our deep dive with permission policies. A permission policy is the core unit of access control in Vultr IAM. It defines what actions are allowed or denied on which services and optionally on which specific resources. As discussed, there are two types of policies. First are Vultr-Managed policies. These are predefined and maintained by Vultr across all major domains. Let's click on one to inspect it further. Here, as you can see, the permission definitions are immutable, meaning you cannot edit a managed policy. However, you can expand it further to fetch the details. Also, you can assign a managed policy to a user or a group, which makes them a convenient starting point for common access patterns. The second type are custom permission policies. These are precise, bespoke permission sets for use cases that no managed policy covers. This is where fine grained access control really comes into play. Let's create one. Click Add Permission Policy button. Start by giving it a name and an optional description that helps your team understand the intent of this policy. Now, in the policy editor, you can select the service or product you want to scope this policy to. Let's choose instances, then click Add Service. The policy editor then exposes a full action set available for that service. You can now individually allow or deny actions such as create, list, update, delete, or read. Next, rather than granting over-permissive access across all instances, we can scope this policy down to a specific resource. I have an instance already running on my account. Let's add its UUID here. Click Add UUID to bind this permission policy to that specific resource. Once you are satisfied with the configuration, click Add Permission Policy to save this. As soon as it is created, it will appear in the list in the Permission Policies page. Let's click on it to open its detail view. Here, the Attach Entity section allows you to bind the policy to user or group that have the permission to access it. From this point, the attached user will have exactly the access defined in this policy and nothing more. Scrolling down further, you'll see the policy section, which renders the full permission definition, listing permitted services, actions, and specific resource IDs in scope. You can also toggle between a human readable rendered view or the raw JSON format, which is useful if you want to version control your policies or replicate them via the API. And to make changes, you can even use the Edit Policy button that allows you to update the configuration at any time. Now let's move on to roles. In Vultr IAM, a role is a collection of permission policies that can be assigned to or assumed by an identity. An assignable role is a role that is permanently attached to a user or group. As long as the role is assigned, the identity continuously holds all the permissions defined within it. To create one, simply click Add Role button in the Roles page. Start by giving it a name and an optional description. Then in the Permission Policy section, select the policy you want to attach. Once done, click Add Role. Upon creation, click the role to open its detail view. Here from the Attach Entity section, you can select your target user or group and confirm. You'll also notice that you can attach additional permission policies to this role or detach existing ones at any time, giving you the flexibility as your access requirements evolve. Let's now talk about assumable rules. An assumable rule works very differently. Rather than being permanently held by an identity, it is temporarily assumed for a bounded period of time. For an assumable role to work, you must define a role trust, a declaration of which entity is permitted to assume this role. On Vultr, role trust can be set to an organization user, organization group, or an OIDC issuer for federated workloads. For demo purposes, we'll go ahead with the OIDC issuer path An OIDC issuer registers trusted external identity provider such as GitHub Actions or Okta with Vultr IAM. Vultr can then cryptographically validate the JWT tokens that this provider issues and allow workloads presenting those tokens assume this role. Since the OIDC issuer creation is API only, let's switch to our terminal to perform the required actions. First, we fetch the public keys from our identity provider's JWKS endpoint. Here, we are referring to GitHub Actions. This returns a JSON response containing a keys array. From the first RSA key, note down the KID, N, and E values, as these are the public key components that Vultr will use to verify GitHub's JWT signature. Now let's register this issuer with Vultr by making an API call. As you can see, the response confirms the creation and returns an ID for this issuer, which indicates that Vultr now trusts JWT tokens signed by GitHub Actions and can validate them cryptographically. Now let's switch back to the console to finally create an assumable role. In the roles page, click Add Role and this time select Assumable Role, provided a name and an optional description. Next, in the Role Trust section, select OIDC Issuer as the trust entity type. Then, from the drop down, select the GitHub Action Issuer we just created. Now, let's configure how this role can be assumed. Vultr gives you two options here. If automatically selected, the role is assumed implicitly once the trust conditions are satisfied. Whereas, if manually selected, the trusted entity must explicitly call the assume role endpoint and select the session length upfront. It is worth noting that if you're working with Vultr API directly, the assumption model can be configured with further granularity. Refer to the Vultr API section in the IAM platform documentation for full details. Now set the trust validity expiration. This defines how long the role trust configuration remains valid before it needs to be renewed. You can optionally define conditions to further tighten who can assume this role even within the trusted issuer. Finally, attach the relevant permission policies to this assumable role. Once done, click Add Role. Upon creation, click the role to open its detail view. From here, you can fetch the role metadata, including the role ID, trust configuration, and attach policies. You can even update the trust conditions for more granular control by applying the operator and values or attach and detach policies at any time. And if your access environments evolve over time, Vultr gives you the flexibility to convert an assignable role to an assumable role or vice versa via the update role API endpoint. Simply specify an updated role type along with the relevant fields in your request body, and once created, you can attach appropriate entities for an assignable role or configure role trust for an assumable role. And with that, we have covered all the essential pillars of Vultr IAM. Incorporate these into your organization's access model, and you will have a solid scalable foundation for least privilege on Vultr. For deeper insights, refer to the full IAM platform and support documentation linked in the description.
To summarize, Vultr IAM enables fine grained access control by combining permission policies, roles, and role trusts to define exactly who can access what and under which conditions. This allows you to enforce least privilege access, manage temporary and permanent permissions effectively, and securely handle both human users and automated systems across your infrastructure. If you're ready to try this yourself, explore IAM within your Vultr account and start implementing fine grained access control today. To get started, claim $250 in free credits on a new Vultr account using the promo link attached in the description below. For any questions or to connect with other developers, join the discussion on the Vultr community forum. Thank you for watching, and we hope this tech talk helps you implement secure and scalable access control using Vultr IAM.